Welcome, and now we look at a slightly different case. We're still interested in looking or knowing more information about the population mean, but now we're looking at comparing the population mean among two populations. And so what do we do, right? And so we revisit our test tree and say, okay, well, we follow it through, and so we start off here, and then we say, okay, number of populations, okay, that's two. We're interested in the mean, so we have to do a two sample T and Z test. And so, okay, naturally you're thinking, okay, we just finished the one sample case for the mean, and we did both the T and the Z. So now it's just going to be like we get another T statistic or Z statistic, get a p-value, or get a calculated margin of error for a confidence interval. Yep, pretty much the same story. Okay, um, but things are going to change slightly. So just as a reminder, at the end of the chapter 17 videos, there was that idea of robustness discussed with the t-test, and so I tried to capture all of the conditions for the t and the z in this nice little list here. Okay, so both the t and the z require IID observations, and we get that by SRS, and then the characteristic needs to be normally distributed, or in the case of the t-test, if we have n is greater than 30, that's generally enough. And then in the case of the z-test, we need sigma to be known. If sigma is unknown, that's again where we do the t-test. And then also for the t-test, we can have the conditions that we don't have outliers. And then if we have a smaller small or even a moderate size sample, for our purposes, there should be no strong skewness present. Okay, so those were the one sample conditions. Two sample, you might expect that many of those are going to carry forward, and they actually do. So in the two sample case, the conditions that we need to satisfy are observations in each sample. Again, we're going to have two samples because we have two populations, need to be IID. And so we have to make sure that they are collected by SRS. Second, we need that the characteristic measured is normally distributed. Okay, that's in line with number two above. Okay, makes sense. And then just a note on that, in practice, it's actually just enough to make sure that the distributions are similar shapes and that they have no strong outliers. So that's sort of in step with that 4 and 5 condition, because normality again is generally pretty hard to satisfy. And third, we're not going to talk about the z-test, but in that case, that's a scenario where you would have to know the population standard deviations. And in the t-test case, we have to have that the population standard deviations would be unknown. Okay, and then also for the t-test, we need that each sample is at least 5. Okay, like there's 5 members or 5 observations in each sample that we get. Okay, so those are the conditions that we need to satisfy. So as we go forward and work in our one example here today, we're going to verify these conditions. Okay, and then the next thing is, okay, once the conditions are satisfied, we need to do the calculation, right? So how do we do that? And we're not going to do that in this video, but just so we're aware what we have to work with, we have 4 unknown quantities when we're working with the two sample t-test, right? We don't know the population means, we don't know the population standard deviations. That's why they're in red. They're unknown. But we do know the sample sizes for each sample, the sample means, and sample standard deviations for each sample as well. Okay, and I just wrote those out symbolically so that you can associate the symbols with each of those. Okay, and so when we do, we're going to focus on hypothesis testing. And so when we do hypothesis testing for to compare the population means, we do it by analyzing the difference. So mu1 minus mu2, and then of course you can rearrange, and that's the same as mu1 equals mu2. And this is similar to what we did in matched pairs, right? You did one minus the other and called that the difference, and then you looked at that, and that's actually going to be our strategy going forward. But the only difference here is that matched pairs was really just one population in 2 specific observations of it. Here we have 2 distinct populations, so that's kind of the difference. So so again, here when we're doing the 2 sample t-test, we're not going to do the 2 sample z-test, but the 2 sample t-test, we have to satisfy these 4 conditions, and then we can go about the calculation that we'll see coming up.